Okay, we're going to do number 1. We were given that ABCD is a parallelogram. So let's make sure we know which one that is. So this guy, ABCD, is a parallelogram. We also know that DE is perpendicular to AB, and CF is also perpendicular to AB. They want us to show that this guy right here, DEFC, is a rectangle. Okay, so let's get started. How are we going to do that? Well, we know that DC is going to be parallel to EF. So, let's start with that. ABCD is a parallelogram given. Now, from that, I want to use that this guy and this guy are parallel. So let's say that DC is parallel to EF. Opposite sides of a parallelogram are parallel. Or another way of saying it is quad is a parallelogram if and only if opposite sides are parallel. Okay, now how are we going to prove that this guy right here is parallel to this guy? Well, if we treat these angles here like same side interior angles in parallel lines, then we could use that if same side interior angles sum to 180, that the lines are parallel. Okay, so we're going to definitely need these two statements. So let's start with that. DE is perpendicular to AB, and CF is perpendicular to AB. This is given. Because of that, we know that angle DEF is going to be equal to 90 degrees, and angle CFE is also equal to 90 degrees. Why? Perpendicular lines form right angles, and right angles measure 90 degrees. Now, what we can do is, well, we know that these two angles, angle DEF plus angle CFE equals, they sum to 180 degrees. Well, because they sum to 180 degrees, this is just an addition property. Okay, we know that we can say that DE is parallel to CF. Why? Well, lines are parallel if and only if same side interior angles or consecutive interior angles are supplementary. Okay, now we can now say that this guy right here, the guy that they want us to prove is a rectangle, is a parallelogram. So let's say that DCFE is a parallelogram by definition. Why? Because if quad's a parallelogram if and only if opposite sides are parallel. We did that from this and this. Now, interestingly, we're going to use the method with showing one right angle. Okay, we know that there is a right angle. From here, DEF or CFE, we just really need one of them. If we use one of them, and we use it's a parallelogram, we could also say parallelogram DCFE is a rectangle. Why? Why are we allowed to say that? From the method we went up above here. Show that a parallelogram that has one right angle is a rectangle. Okay? Parallelogram with one right angle is a rectangle. So let's take a look. Quick summary. So we wanted to use method 3, right? We knew that this red guy again was a parallelogram, so it made it easy to show at least one pair of sides are parallel. Then we also used this statement to prove the green that that DE and CF are parallel to each other because of the addition property, because in parallel lines, consecutive interior angles, if they're supplementary, the lines are parallel. Okay, so we got that DCFE is a parallelogram. Then we just had to show that there's one right angle, but we already did that in the beginning, and so we just used that again, and now we can say it's a parallelogram.